So this is a function. It is a mathematical relationship between two variables where every input value has one output value. Functions is used in real world in economics. You know, economics, they deal with money, so money and time. So there's an input there and also a variable, so there are two variables there. And it is also used in predicting disasters. We are talking about tsunamis and so on. It is also used in medicine, just to cure diseases. So it's a very, very important concept. Right, we are going to look at linear function, and if you can have time, we are going to look at quadratic functions. So the first type of function is called linear function, or sometimes some books they will say it's a straight line function. A linear function is a function of the form y is equals to mx plus c. Or some books you will see that they will write y is equals to ax plus q. It's just basically the same. So we are going to concentrate on this first one, because when you go to grade 11, you see this on your formula sheet. If we make C0 and M1, you are going to see that you are going to have a function like this one, y is equals to x. And this is the function, this is what is called the mother of the functions of linear functions. The mother of linear functions. Why is it the mother? Because all the other functions, you are going to see that they are going to come from this. So that's why it is the mother of functions. The mother in quotes, because this one is not a mathematical term. So we are going to plot this function to see what is it like. So you are plotting, and remember, when you plot, it has to be a little bit accurate. It has to be accurate, and in most cases during examinations, we give you a grid or a graph paper so that you can plot it there. So when you are plotting, you just need to have your x values, which is your input value, like what we have said from the definition, and you are going to also have your output value, which is your y values. So you are going to have a table. You are going to have a table, and this table is just going to have two rows. The first row, you put your x, which is your input value. Then it's your row there. Then the other row is going to have your y, which is going to be your output value. Right. Remember, the mother of the function is y is equals to x. Then you choose your input value. It depends on where do you want to start from. But normally, if you can have 5 or 6 input values, it is going to be enough for you to see how the graph is like. So we can start from, say, -2, and it means the next input value is going to be -1, then 0, 1, and 2. Right, so we are putting the input value into the function. Remember, the function is y is equals to x. So what this means is that where there's x, you are supposed to put what? -2. So if you put -2 where there's x, your output is going to be also -2. And if you put -1 into where there's x, you're going to see that your output value is going to be also -1. And the same thing with 0, the output value is going to be 0. The same thing with 1, the output is going to be 1. And also the last one, if the input is 2, the output is going to be 2. So we are now having our table with the x values and the y values, the input and the output. Then we are going to sketch the graph now. Remember, for you to sketch the graph, you are going to have what is called the ordered pairs. The ordered pairs will be, like in this case, it will be -2, -2, then -1, -1, 0, 0. So these ones are going to be coordinates. I know you know these things from your grade, from your grade 9. Then 2, 2. So it's -2, 2, -1, -1, 0, 0, 1, 1, and 2, 2. Hence, to plot this one, you need a Cartesian plane. Remember, from grade 9, a Cartesian plane has the x and the y axis. The x-axis is the horizontal, that's the horizontal line, and the y-axis is the vertical one. And where these axes meet, we call it the origin, which is the point 0, 0. And you need to have your x values and also your y values. Remember, above 0, the y values are positive. So it's going to be 1, 2 here, 3, I can even say 4. And here I'm going to have 1, 2, 3, 4. Then to the left of 0, the x values are negative. Remember, -1, -2, -3. Right? Because you may not have a graph paper or a grid paper, you can just draw it, just draw the Cartesian plane roughly. And below 0, the y values are negative, so I'm going to have -1, -2. I can go on, maybe -3, but I know that my y values are starting from -2 up to 2, so everything is accommodated. Then I need now to plot. When you are now plotting the points, remember -2, -2. The x value here is -2. So can you go to -2 and also go to -2 on the y-axis, -2 on the x-axis, and -2 on the y-axis. Where they are meeting, then put a dot there. You can put a dot. Sometimes you see that they can put a cross. The next point is going to be -1, -1. So you go where there's the x-axis, so go there, -1. On the y-axis, go to -1. Check where they are meeting, put a dot there. 0, 0, like I said, it is the origin, so you are just going to put it on the origin. 1, 1. It's 1. You go to on the x-axis, go to 1. On the y-axis, go to 1. Then where they are meeting, you put a dot there. Right? Then the last one is 2, 2. Right? Where they are meeting, you put a dot there. And if you are using a graph paper or a grid paper, you are going to see that the points are going to be in a straight line. So you can even join them with a ruler. But unfortunately here I'm not having a graph paper or a grid paper. I can just join it, but I'm expecting the points to be in a straight line. So I'm going to join them and Here I come, I'm almost there. Then there comes my mother of functions, which should be a straight line, as you are seeing. And I am putting those arrows because it means it should continue. Remember, I just choose my input value from minus 2 up to 2, and I can even go on. If I have time, I can even go on up to minus maybe minus 10, of which it is not the limit. The limit is going to be minus infinite up to infinite, and the output value is going to be from minus infinite up to also infinite. But for this one, if I put those arrows, it means that they are going to there. So this is the mother of functions, which is going to be, and I have to label the function y is equals to x. So we now have the mother of functions. And let's study this diagram, or this, not diagram, but this line. If you see this line, as the values of x are increasing, like here, if I check at 3, I'm seeing that the y value is also going to be 3. If I try to extend it, when x is, say, 4, the y value is going to be 4. So as the x value is increasing, the y value is increasing. So we call this function, it is an increasing function. It is an increasing function. It is an increasing function. As the y value increases, the x value increases. As the y value decreases, like here, see at minus 3, that is decreasing, the y value is going to be minus 3. So it means as the y value decreases, as the x value decreases, the y value is also decreasing. So it is an increasing function. Right, we also need to check what is the domain of this function. When we are looking at the domain is the x values the function can take. So if I want at any given point, I want an x value. For example, at any point, just say between 2 and 3, I go to the graph, I draw a straight line going to the x-axis, which means I will read the x value between 2 and 3. And this, so it means that I can get the x value at any given point on the graph. So the domain now is just simply x is an element of real numbers. X is an element of real numbers. If you check in your textbook, you will see the symbol for real numbers. Remember, as mathematicians, we don't write the whole thing real numbers. No, we don't write like that one. We just use symbols. We are very lazy, but we are very intelligent because we just use symbols. So make sure you check the symbol for real numbers. But x is going to be an element of real numbers, which means x can take any value within the Cartesian plane. There's nothing that limits here. Then there's what is called the range. Right, the range, this is the y value that the function can take. So if I go to any point on the graph, I can read the y value. For example, if I can just go to this point, let's say at a point, any point on the graph, so I can read the y value by drawing a horizontal line to the y-axis, right? You can just draw a horizontal line to the y-axis and you read the y value there. So if I check, I can get the y value at any point. I can get the y value at any point, which means that the y, the function, the y value the function can take is just real numbers again. It can take any real number. So the domain is x is an element of real numbers, and the range is y is an element of real numbers. And remember, there is also a different notation that you can use. You can say x is an element from minus infinite up to infinite. Maybe you should know the symbol for infinite. Or you can say here for the range, y is an element from minus infinity again up to infinite. So that is the range. You can either use the first one or the second one. Right. Then, like we said, this is the mother of the function. So let's see the other, maybe the children or the husband maybe. Remember, even the husband come from the mother. So remember, we are still in this with this, and we said from this we got this. Right, let's just say C is 1. Like you are now going to have x plus 1. So this, it means that it's coming from the mother, which is coming from the function y is equals to x. So what we have changed here is only that the value of C is now what? 1. So what are we saying here? We are going to investigate what is the effect of C. So here we can say effect, we can investigate the effect of C. So with this only one graph, we may not see clearly. Let's also say that we also have another offspring of this mother graph, which can be x minus 1. So we want to see what does changing C has the effect. What is the effect from the mother graph? So it means we need to plot again these graphs on the same set of axes. The graphs or the lines, y is equals to x plus 1, and the line y is equals to x minus 1. So let's say the first one, that is y is equals to x plus 1, let's say it's y1, and the second one, which is x minus 1, let's say it's y2, so that we can differentiate these linear functions. Remember, all these ones are linear functions. Right, like we have said, we can still have our table. So can you draw a table with 2 columns? In this case, you can even have 3 columns, because we are going to have two functions here. The x value, which is the input, then put y1, and the other one y2. Right, the input values, like I said, you can start to where you want, but if you can start with from -2 up to 2, you can have enough points to see the trend. -1, 0, 1, 2. Right. So what this means is that on y1, where does x put -2, and see what is going to be y1. So if you put -2 there, it means you're going to have -2 plus 1. And what is -2 plus 1? It is -1. Then if you put minus 1 where there's x on the first function, which is y1 is equal to x plus 1, you are going to see that you are going to have minus 1 plus 1, which is 0. And if you put 0 where there's x, you are going to have 0 plus 1, which is 1. If you put 1 where there's x, you are going to have x plus, 1 plus 1, which is going to be 2. If you put 2 where there's x, you're going to have 2 plus 1, which is going to be 3. Then I'm done with that one, first function. Then the y2 is x minus 1. So where there's x, let's put minus 2. So I'm going to have minus 2 minus 1, which is going to be minus 3. And if I put minus 1 where there's x, I'm going to have minus 2. If I put 0, I'm going to have minus 1. If you put 1, which means I'm going to have 1 minus 1, it's going to be 0. And if you put 2 there where there's x, you're going to have 2 minus 1, which is 1. Then we are done with this one. We are going to have the ordered pairs. Remember, for the first one, it is going to be minus 2 minus 1. Then the next one will be minus 2 0 0 1 1 2 and 2 3. So we can, let's just plot where we draw the mother function, the first one, y1, which is x plus 1. So can we go to minus 2 and go to minus 1 on the y-axis? Minus 2, remember, is on the x-axis. Where they are meeting, right, we plot a point there, put a dot or a cross. Then the next one is minus 1 0. That is where sometimes some learners, they struggle here. Make sure that, remember, you are on minus 1 and 0. When y is 0, remember, it's the x-axis. So you are plotting exactly where there's that minus 1. Right? Then, even the next point, some learners, they struggle with this one. Remember, your x is 0, which is on the y-axis, on the origin, and your y is 1. So you go to where there's 1 on the y-axis. Then the next one, when x is 1, y is 2, this one should be symbol. Go to 1, go to 2, then where they are meeting, that is where you put the dot. Then the last one will be 2 and 3. So you go to 2, then they're meeting at where they're meeting, that is where you plot the dot. Then, just like that other one, the mother graph, you just join the points. Right. And just like this one, remember, I started at minus 2. I can even start from even minus 5. So I'm putting arrow, which means that it can continue like this, just continuous. Right, this is, then I have to label my graph. Remember, you have to label it, which is y1, which is equal to x plus 1. That is the line y is equal to x plus 1. Then you have to plot again the line y is equal to x minus 1. And at minus 2, the y value is minus 3. Go to minus 2 and minus 3. Right. Put a dot there. Then go to minus 1 and it will be at minus 2. Minus 1, minus 2. Go to minus 1, go to minus 2. Then where they are meeting, put a dot there or just a cross. The next one, will be at 0, it's minus 1. That is also a problem to most learners. Make sure you go to 0 with x, then go to minus 1. Then where they are meeting at minus 1, which is on the y-axis. Same thing with this one. When x is 1, y is 0, the y0 is on the x-axis. So that is where you plot it. Then when it is 2, you go to 1. 2, you go to 1. So where they are meeting, put a dot there. Right, let's now join the points. Right, if you join the points, like I said, if you are having a graph paper, it should be also a straight line, and you will label the graph, which is x minus 1. And if we can start these graphs, you have seen that these graphs are facing the same direction. They are just facing the same direction, and they are almost behaving in the same way. So it means obvious. These graphs, if you compare with the mother graph, they're almost in the same way. Both graphs are also what? Increasing. If there's 2, y1 and y2, they are also increasing, just like the mother graph. And if we can check the range of these two again, you are going to see that these two, the range of these two is still going to be the same as the range of the mother graph. And even the domain of these two, that is y1, which is x plus 1, and y2, which is x minus 1, is still having the same range with the mother graph, which is y is equals to x. But there's something that is different here. If you check, let's start with the line y1 is equals to x plus 1. What is different here is that where it cuts the y-axis, that is the difference. In the mother graph, which is y is equals to x, the graph cuts the y-axis at 0. But now, with this graph y is equals to x plus 1, it is cutting the graph. The graph cuts the y-axis at 1, which means that's why there's this difference. So it means that to get y1, the mother graph has been shifted upwards by 1 unit. It has been shifted upwards by 1 unit. If you can check at any given point, like for example, if you check the point 2, 2 on the mother graph, the new graph, which is x plus 1, it is now at 2, 3, which means it has been shifted upwards by 1 unit. Then let's check this other one, which is y2 is x minus 1, and see what has happened here. This graph, if you can closely check it from the mother graph, it means that to obtain the graph x minus 1, you have to shift the mother graph 1 unit down. So it is this graph which is now cutting the y-axis cuts the y-axis at minus 1. What does that mean? It means that the mother graph has been shifted vertically downwards. Remember the word vertically downwards, it means that you are shifting it everything down by what? By 1 unit. It's just like when you are moving, say you are moving 4 units or 4 meters from where you are moving everything. You don't leave your feet or what, you just move everything, so your whole body moves 4 meters. So just like this one, the mother graph has been shifted 1 unit down to get the graph x minus 1. Then so what does that mean? It means C, if C is greater than 0. What does that mean when we say C is greater than 0? It means if C is positive, the graph is shifted vertically upwards. Because here, if you check here, y1 was x plus 1, which means C here is positive and it has been shifted by 1 unit upwards, and that's why we are saying if C is greater than 0, the graph is shifted vertically upwards. By how many units? In this case, it will be by C units, because this is C. So we can shift it by C units. In this case, it's 1. Then, if C is less than 0, like here, we mean that when you say C is less than 0, it means C is negative. And in this case, your y2, which was x minus 2, it means that C is minus 1 in this case. So it means if C is negative, the graph is shifted vertically downwards by C units in this case, by C units. Remember, we are now generalizing from the form that we say linear functions are, which is y is equals to mx plus c. We are now generalizing that if C is less than 0, slash C that we talked about, then you just shift the graph downwards by C units. You just shift the graph downwards by C units. So that is the effect of C. It's either you shift it upwards or downwards, depending on the value of C. And we have seen that if C is positive, you just shift it upwards. If C is negative, you just shift it what? Downwards. And so what this means is that you can even sketch a graph, any graph. You can sketch any graph without even having a table. By just, if you agree, you know that the mother graph, the mother graph is passing through the origin. So you can sketch any graph by just knowing that what is the effect of C. Then you can sketch any graph by shifting either upwards or downwards. Let's now see the effect of M. The effect of M, remember, our function in general is y is equals to mx plus c. So let's see the effect of M. And for you to find the effect of M, you need to keep C maybe constant. And the easiest part is just to make it C0. Let's start with the mother graph. And we are going to change M. In this case, M was 1. So I'm going to change M to be, say, minus 1. and I think this is the closest from the mother graph, because it's just having a minus there. And I'm also going to just have maybe change and put, say, 2x there. Y is equals to 2x. Maybe to differentiate these graphs, let me say y1 and y2. So I'm now having functions y is equals to x, y1 is equals to minus x, and y2 is equals to 2x. Then I'm going to have a table to check the output values. And the table, like I have already said, we are going to have, in this case, I don't need to have the mother graph. I'm just going to have the y1, which is minus x, and y2, which is 2x, because already the mother graph, I know the points. So I'm just going to have the input value, and then I will say y1 and y2. Like I said, let's still stick to this thing where we are starting from minus 2 and we end at 2. So it's minus 2, minus 1, 0, 1, 2. Right, so now we are going to work out what is the output values. The output value for the first one, when x is minus 2, we are going to see that the output value is going to be 2, because you are saying minus into minus 2, which is going to be 2. Then when x is minus 1, you are going to have minus 1 minus 1, which is going to be 1. Then minus, then 0 is going to be 0. When x is 1, you are going to have the output value of minus 1. When x is 2, you're going to have an output value of minus 2. Right. Then the other function, y is equals to 2x. When the input value is minus 2, it means the output value, to get the output value, I'm going to say 2 times minus 2, which is going to be minus 4. Then when the input value is minus 1, I'm going to get the output value of minus 2, because I'm going to say 2 times minus 1, which is going to be minus 2. Then when the input value is 0, I'm going to have the output of 0. When input value is 1, I'm going to have an output value of 2. Right? When the input value is 2, I'm going to have an output value of 4. Right, then I'm going to try to sketch the functions. And remember, I think by now there's no need for us to just to pair the points, because you now know how to do it. But in this case, maybe let's redraw the mother graph quickly, because I have the other one is now messed up. So remember, you have to put your Cartesian plane, the x-axis, your y-axis here vertically is the y-axis, the horizontal one is the x-axis. Then when you are putting your points on the x-axis, remember there's no need for you to go to minus 10. You can just start from minus 3 or even minus 2. So there's no need for you to go to minus 10 then. So you just put in minus 1, minus 2. Let's also put minus 3. Then to the right of 0, I'm going to have 1, 2, and 3. I can end there. But on the y-axis, I just check here. I'm seeing a minus 4 and 4. So it means I can even go up to 5 if it is possible. So it's 1, 2, 3, 4, 5. Then below 0, remember we said it's negative numbers there, so I'm going to go to -1, -2. I'm going to put -1, -2, -3, and -4. If it's possible, you can just put -5 also. Right? Then let's plot the mother graph. If you still remember the mother graph, when x is 0, y is 0. When x is 1, y is 1. When x is 2, y is 2. When x is 3, when x is 3, y is 3. So when x is -1, y is -1. When x is -2, y is -2. Right? I'm just redrawing the mother graph. You can also do the same thing so that we can have a clear picture of what is happening. Then we are going to plot now the new graph there, or the new line, which is y1 is equal to -x. And when x is, in this case, when x is -2, when x is -2, y is 2. It is going to be in the second quadrant, if you check. -2, 2. Then when x is -1, y is 1. -1, y is 1. Plot it there. When x is 0, y is 0. When x is 1, y is -1. When x is 2, y is equal to -2. 2 is -2. And it means that you can join the points. And can you join the points and label the, you label the graph, which is -x. So y is equal to -x. I've seen that this graph is also a straight line. Remember, you should use a ruler and to join the points. If you are using the graph paper, it should be a straight line. Then maybe before we discuss what is happening here, let's just plot the other graph, which is y2 is equal to 2x. When x is -2, y is -4. Let's check where they are meeting. They are meeting down there, which is, then when x is -1, y is -2. -1, -2. 0, 0. It's passing through the origin. 0, 0. Then 1, 2. 1, 2. We go to x. When x is 1, y is 2. 2, 4. 2, 4. When x is 2, y is 4. Where are they meeting? They're meeting there. Then you join the points. Join the points. It should pass through the origin. So y, then you label the graph, y is equal to 2x. Right. From this, it means that the mother graph, if you compare it with y1, it's a reflection in the x-axis. It's just like we are putting a mirror in the x-axis. So it's a reflection in the x-axis. Then, because it's if you put a mirror on the x-axis, it is going to, you see, it's now down, it's below the x-axis, and this side of 0, it is now up. So it's a reflection in the x-axis. So this is what has happened from the mother graph to y is equal to -1. It's just a reflection in the x-axis. So then if we check the graph of y2 is equal to x, it's just almost the same, but the steepness or the slope of the graph is is no longer the same. It has increased. The steepness is now steeper. So it means when you change M, it is now what? Steeper. I can remove it. Thank you.
Okay, you can now wrap up and say thank you, Sunda.
Right. So we are going to meet in the next episode. Then I'm going to just quickly round up about the effect of M. Then we continue from there to look at the quadratic functions. Thank you very much. Let's meet again next time. All is well that begins well and ends well. Thank you.